we've discussed there yung movement nung bawat joint. So, for example, for joint B, may movement siyang dalawa, yung delta H at saka yung delta V. Doon naman kay point C, meron tayong delta H. Now, itong mga movements na to, ito yung mga tinatawag nating displacements. Now, in chapter 1, ang ginawa lang natin is binilang natin yung possible na displacements. Now, for this chapter naman, we're going to compute ilan yung mga distances na to. Ilan yung values ng delta H, ilan yung value ng delta V. So, ito yung pag-aaralan natin ngayong araw na to. Okay? So, regarding deflections. Now, here in thrust deflection, ang gagamitin nating method, we term this as the virtual work method. So, what is a virtual? Now, in theory 1, virtual means imaginary or not real, or in essence, but not in fact. So, ano ibig sabihin nun? Virtual, imaginary siya, hindi talaga siya nag-e-exist. Kung baga is dummy lang siya. So, the principle of virtual forces. A deformable structure is in equilibrium under a virtual system of forces. Then, the external work done by the virtual forces going through the real displacements equals the internal virtual work done by the virtual stress resultants going through the real displacement differentials. Principle of virtual displacements. Ay, so, mga principles na to, mas maiintindihan natin through an example. But, again, just want to reiterate, kapag sinabi nating virtual, dito sa theory 1, we pertain to an imaginary or not real structure or loadings. Okay? So, the whole method I'm going to introduce to you, ang tawag natin doon is virtual work method. Here, application din ito nung napag-aralan nyo during your strength of materials. Let's go directly to the example para mas maintindihan natin kung ano ba ang virtual work method para ma-determine natin yung ating mga truss deflections. For this problem, the plane truss shown, yung mga members, meron daw siyang cross-sectional area equal to 1,300 millimeters squared. And that is your modulus of elasticity, and that is equal to 200 gigapascal. Now, you're required to determine the horizontal displacement or delta H at point C. So, sa figure na to, yan, ang hinahanap ng problem na to is kung i-apply natin itong 40 kilonewtons, itong 10 kilonewton, 10 kilonewtons, what would be the movement of point C in the horizontal axis? So, kapag in-apply ko itong mga loadings na to, syempre, obviously, mag-move si point C. But, what would be the direction? Will it move to the right or will it move to the left? And, ilan yung movement na yon? Ilan yung distance na yon? So, the height of AB is length, or the length of AB is 3 meters. Wait lang. Pwede pa-record, medyo choppy kasi. Okay. Then, the length of AD is also 3 meters. So, this truss is a 3 by 3 truss. Okay. So, as you can see there in the problem, the area and the modulus of elasticity is constant. What do we mean by constant? Yung mga area ng bawat member ay pare-pareho. Yung modulus of elasticity ng mga members ay pare-pareho din. Can you hear me clearly? Mahina ba yung boses ko or malakas? Or okay lang? Kindly chat dun sa may chat box. Tap namok no ipigpigsakpay or napig sa unay. Okay lang po. Okay. So, diretso tayo. So, this is the problem for illustrative problem number 1. Now, there are steps we are going to consider to determine kung ilan yung movement horizontally ng point C. Step 1. Evaluate the member forces and reactions using method of joints or method of sections. Paano to? Di ba ito yung, pinalaki ko lang, ito yung truss. So, yung truss, At point B, meron tayong external load na 40 kilonewtons at saka 10 kilonewtons. At point C naman, meron tayong 10 kilonewtons. At point A, this is a hinge support. At point B, that is a roller support. So, sa step 1, ang sabi doon, you have to determine the reactions for each support. So, kailangan nating isolve yung value ng reaction sa D. I take summation of moments at point A. Masasolve ko yung reaction at D, which is equal to 50 kilonewtons. If I take naman summation of forces along the y-axis, ang masasolve ko dito, VA is equal to negative 30 kilonewtons. Ano tong negative 30? Now, if you try to look at my diagram, dito kasi kay point A, inassume ko na upwards si reaction at point A. Pero lumabas sa calculations ko na negative siya. Ibig sabihin, hindi pa taas si point A. Dapat si point A ay pababa. Okay? So, ang vertical reaction ko kay A ay 30 kilonewtons. If I take summation of forces along the horizontal axis, I can solve for HA, which is equal to 40 kilonewtons. Yan. So, ang unang ginawa natin, ay sinolve ko yung mga reactions sa support. Next, kapag nakuha ko na yung mga reactions sa support, using method of joints or method of sections, kailangan ko na ngayong isolve yung mga bar forces. Ilan yung bar force sa CD? Force kay AD, force kay AB, BC, at saka kay AC. Ilan yung mga forces, yung mga bar forces na ito? Now, what I did here, I used method of joints. After using method of joints, ito yung mga naging sagot ko. Hindi ko na pinakita sa inyo yung step-by-step na method of joints kasi masyadong mahaba. Makukulangan tayo sa oras. So again, paano ko na itong 50 kilonewtons na to? If I take joint D, summation of forces along the y-axis, masosolve ko na si CD equal siya sa 50 kilonewtons. Now, you have to take note dun yung direction ng mga arrows. So, from this diagram, makikita ko na si CD, 50 kilonewtons, pero under siya ng compression. Bakit compression? Kasi yung direction ng arrow ko is towards the joint. Again, this was our lesson in previous chapters. Kay member AD naman, it turned out in my analysis, this is equal to 0. Then, member AB, 10 kilonewtons siya, and it is under compression. Same with BC, 40 kilonewtons and under compression. Kay member AC naman, ang lumabas sa calculations ko, member AC is equal to 56.57 kilonewtons and under siya ng tension. Do not just merely look at your screen. Kindly bring out your calculator. Paki-double check po kung tama yung mga values na nandyan sa inyong screen. So, ulitin ko, itong mga values na nakikita nyo sa inyong mga screen, nakuha ko po ang mga ito using method of joints. Okay? So, this is step 1. Again, we are required to determine the horizontal deflection at point C. So, step 1 pa lang na ito eh. Again, ulitin natin. Ang step 1, isosolve natin yung mga reactions sa mga support, then determine the bar forces, either using method of section or method of joints. Okay po? After step 1, we have now step 2. Anong sabi sa step 2? To determine the horizontal deflection at joint C, remove the externally applied load system and apply a unit load only in a horizontal direction at joint C. So, sa step 2, ang sabi doon, alisin lahat ng mga external loadings. 'Di ba? Originally, kasta DJ, yan yung nakuha mo sa step 1. So, ganito yung original na itsura ng ating truss. So, may mga external loadings tayo na 40, 10, and 10 kilonewtons. Now, pagdating natin sa step 2, alisin nyo lahat ng mga external loadings. So, ang matitira yung mismong truss at saka yung mga support. Okay? And then, pag naalis nyo na yung mga external loadings, ang sabi doon, apply a unit load only in horizontal direction at joint C. Diba sa problem na to kasi, you are required to determine the horizontal displacement at joint C. Since yun ang required sa problem na to, horizontal displacement, so yung unit load na 1, ilalagay natin kay point C, pero in a horizontal direction. Kasi yun yung hinahanap ng problem. Now, dito sa problem na to, inassume ko na si joint C, magmumove siya to the right. Okay? Kung mag-solve naman kayo, nasa sa inyo kung to the right or to the left. Depende na sa inyo yon. Basta ang importante kasi dito, yung paglagay mo ng 1 unit load ay nasa horizontal direction. Now, here, dito sa step 2, basahin nyo yung worded problem. Kasi sa yung worded problem, ang sabi doon, you are required to determine the horizontal deflection at joint C. The word nga horizontal deflection. So, from that statement na horizontal deflection, numapan kayon kani step 2, dapat yung inyong 1 unit load ay nasa horizontal direction at joint C. Nasa sa inyo na kung to the right or to the left. Ma-check naman natin mamaya. But as for me, my assumption here, my joint C will move to the right. So, dun ko ilalagay si 1. Pagkatapos na nilagay natin si 1 unit load, you have to use again the static equation, summation of moments, summation of forces along the y and x axis para ma-solve yung mga reactions kay point A at saka kay point D. Now, after using the static equations, at yung mga reactions kay point A at point D ay yan. Paano ko nakuha itong mga values na to? Itong 1, 1, and 1. Again, if I take summation of moments at point A, makukuha ko si value na D, which is equal to 1. Kapag nag-summation forces naman ako along the y-axis, doon ko nakuha itong 1 na to. Then, horizontal, doon ko nakuha itong 1 na to. Okay? Kapag nakuha nyo na yung mga reactions, next is using again method of section or method of joints, kukunin natin yung values ng mga members. So, parang yung dun sa step 1, I used method of joints again. After using method of joints, ito na yung mga sagot ko. 0 yung nakuha ko kay AD, 0 kay AB, 0 kay BC, 1 kay CD, and square root of 2 kay AC. Now, take note of the direction of my arrows. Itong CD na to, the direction of my arrow is towards the joint, kaya si CD ay under compression. Si AC naman, the direction of the arrow is away from the joint, so si AC ay under tension. Okay po ba tayo dito sa dito kay step 2? Di panang ala kadagiti nga values 1, 0, and square root of 2. I used here method of joints. So, after this step 2, mabana ko di next nga procedure. I can solve now for the horizontal deflection at joint or at C by using this equation. Now, this equation looks familiar. You've encountered this equation during your strength of materials. So this is an application of what you have learned during your strength of materials. Wherein P, that is the force, L, that is the length of your material, A, that is the cross-sectional area of your material, and E is the modulus of elasticity. Yung U na to, yan yung tinatawag nating virtual. And paano gamitin itong equation na to? Let me show you on how to do that, to use this one. Yan. So, kanina, itong figure na nakikita niyo sa screen, yan yung values na nakuha natin nung in-apply si this should be 40 kilonewtons, yun yung given. In-apply si 40, si 10 kilonewtons, ito yung mga values na nakuha natin. Itong figure na to na nakikita nyo, this is your P system. If you try to read the notes that I have posted, this figure, we call this your P system. And then, sa step 2 kanina, ito yung ating figure. Alright? This is our figure. This figure now, di ba inalis natin yung external loadings? In-apply natin si 1. So, this figure, we call this your U system. Yan. So, ano tong mga figures na to? Bakit ko ginanyan? Now, in using the equation PL over AE times U, mas madali kung iti-table natin yung ating mga data. Now, if we try to put the values in a table, so member AB, ang length ni member AB ay 3. Yung mga length ay given in the problem. So, kanina pinakita ko sa inyo, yung length ni AB ay 3, yung length ni AD ay 3 din. 3 meters yun. And so, using Pythagorean theorem, na-solve ko yung length ni AC, which is equal to 4.24. Now, the cross-sectional area. The cross-sectional area is given in this problem, which is equal to 1,300 millimeters squared. Now, bakit ko sinulat yung A? Kasi pare-pareho naman yung kanilang areas, kaya diniretso ko ng A. Okay lang din. Kay modulus of elasticity naman na E, constant din naman siya, kaya sinulat ko na lang na E. Yan. Then, ano tong P? Ano tong column P forces na to? So, itong P na to, yan. Itong P na to, yung values na nandito sa may column ng P, yan yung mga values na makukuha natin dito sa may P system. Now, if we try to look at member AB, kay member AB, meron tayong 10 kilonewtons. Kaya yun yung 10. Bakit negative? If you try to look at the direction of the arrow, AB is under compression. Now, this is our sign convention. Kapag sinabi nating compression, negative. Kapag sinabi nating tension, positive. Okay? So, again, AB, sa may P system, AB is equal to 10 kilonewtons, and that is under compression, kaya negative. Kay AC naman, AC, 56.57 kilonewtons, positive kasi yung direction ng arrow ko is away from the joint, and that is under tension. Okay po? Yan, dyan ko nakuha yung values ng aking P. Next, paano yung value ng U? Now, itong value ng U na to, yung mga values dito, galing yan dito sa may U system, or yung tinatawag nating imaginary, kaya virtual. So, itong mga values na to, AB0, if you try to look at this diagram, si AB, 0 yung kanyang value. Si AC naman is square root of 2. Square root of 2 is equal to 1.41. Under tension si AC, kaya positive. Under compression si CD, kaya negative. Okay? So, doon ko nakuha si U. After na i-table na natin yung ating mga values, we can now multiply or follow this equation PL. So, P for AB, negative 10 times 3 times U. That is 0. So, 0. Right? Then, negative 40 times 3 times 0 is 0. Negative 50 times 3 times negative 1 is 150. 0 times 3 times 0, 0. 56.57 times 4.24 times 1.41 is 388.2. 338.2. Now, after na nakuha natin yung value ng ating PL times U, we need to take the sum of all of these from 0 to 338.2. The summation of this is equal to 488.2. We are not yet done. So, kapag nakuha na natin yung ating value or yung summation ng lahat ng mga PL over U, next thing we have to do is to follow the formula. So, yung value ng ating PL over U, PL times U, the value is 488.2. Since constant naman kasi si AE, pare-pareho lang siya. So, we're going to divide them by A, which is equal to 1,300 millimeters squared, and E is equal to 200 gigapascal. Now, I'm always telling the students, your unit should be consistent. Laging dapat ang unit ay consistent. If you try to look at this, kilonewtons, meter, millimeter squared, and gigapascal. So, dapat pare-pareho yung ating mga units. So, we have to convert those units para pare-pareho sila. So, the deflection, horizontal deflection at point C, I converted 488.2 kilonewton meters into Newton millimeter. Yung gigapascal, kinonvert ko siya ng Newton millimeter squared. Bakit ko kailangang i-convert? Now, if you try this, to look at this one, gigapascal, ag-cancel di. Newtons, magka-cancel din. Millimeter squared. So, here, ang maiiwan na lang na unit ko is millimeter. So, the deflection, horizontal deflection at point C, the unit should be in millimeters. Kasi yun yung lumabas sa calculation ko. Now, if you try to input these values in your calculator, the deflection now, horizontal deflection at point C, is equal to 1.8 millimeters. Yan. Positive yung lumabas sa calculator. Anong ibig sabihin ng positive? Di ba originally, my truss looks like this. Andito si hinge, andito si roller, and then meron akong brace dito. Yan. So, ang assumption ko kanina, andito si point C. Ang assumption ko, si point C will move to the right. Yan. And lumabas sa calculations ko na ang horizontal deflection at point C is equal to positive 1.88 millimeters. Positive, which means yung direction ko, yung assumed ko na direction kanina na to the right ay tama. Once na yung sagot na nakuha nyo dito ay negative, ibig sabihin mali yung direction ninyo. Okay po ba tayo dito sa example number 1 before I go to the next slide? Yung present ko sa inyo na problem number 1, that is a deflection due to external loadings. Meron din ibang mga factors we have to consider pagdating sa deflection. We have the fabrication error and the changes in temperature. Kapag sinabi nating fabrication error, this is nasa manufacturer na to. For example, if you try to go dun sa my hardware, if you try to order, let's say steel, diba usually ang ginagamit natin ay yung 6 meters. Now, if you try to measure it, yung standard measurement, dapat eksaktong 6 meters. But there are still may mga na adadagi landok ngay nga eksakto nga 6 meters still length na. Some has a length of, let's say, 5.9 meters. Yung iba naman is 6.1 meters. So, hindi naman lahat ng mga bagay are perfect yung ating mga length. There are fabrication errors. Now, we have to take note of that. Baka na iba yung nagbasit mo di difference na nga 0.01 or 0.1. In deflection, malaking bagay na yung 1 mm. Malaking bagay na yun. And changes in temperature naman, since most of the time, in structures, we're dealing with steel. So, steel kasi is sensitive in temperature. So, once na nag-increase ng temperature, yung steel will try to expand. Kapag naman bumaba yung temperature, the steel will try to shrink. Shrink, tama ba yung term ko? Di medyo kasla compress. Yan. So, we have to take note of these factors, fabrication of errors, and changes in temperature. Let's have an example on how to determine the deflection of trusses brought by these fabrication errors and changes in temperature. Now, for this example, you're required to determine the vertical deflection at point D. Assuming that the existing loading in the member BC is too short by 0.08 inches and member CD is too long by 0.06 inches, and the temperature increase is 65 degrees Fahrenheit for all members. The cross-sectional area for each member is 2 square inches. The modulus of elasticity is equal to 29,000 KSI. KSI is kips per square inch. And alpha, or that is the coefficient of thermal expansion, which is equal to 6.5 times 10 raised to negative 6 per degrees Fahrenheit. So, ito yung ating figure. So, ang nire-require dito is the vertical deflection at point D. Para yung ginawa natin in the previous problem, meron tayong step 1 at saka step 2. Diba, kung maalala nyo sa step 1, what we did there, first, we solved the reactions for each support. Tapos, gumamit tayo ng method of joints to determine the bar forces. Now, if we try to look at this diagram, itong problem number 2 na to, wala tayong external loadings. Since walang external loadings, wala tayong makukuha sa step 1. Wala tayong P system. So, skip natin si step 1, proceed tayo kay step 2. Ano ang sabi ni step 2? Alisin yung mga external loadings, then apply a unit load. Yan. Since wala tayong external loadings, so our truss will remain like this one. Then, we're going to apply a unit load. Now, if we try to read again the problem, determine the vertical deflection at point D. So, vertical deflection siya. So, yung magiging direction ng ating unit load ay along the vertical axis. Now, the point we are going to consider here is D. So, kay point D, maglalagay ako dito ng unit load na vertical, either up or downwards. Now, my choice would be downwards. So, this is my assumption. My assumption here, point D will move downwards. Kaya doon ko ilalagay si 1. Again, nasa step 2 tayo. Iniskip ko si step 1 kasi walang external loadings. So, nag-proceed ako kay step 2. After na nailagay ko si unit load na 1, using the static equations, masosolve ko ngayon yung mga reactions kay A at saka kay C. Baka manan adatag damag kasanok nga naala di 0.5 kani C. If I take summation of moments at point A, makukuha ko si C. Summation of forces along the y-axis, makukuha ko si A. Wala na pong summation of forces along the horizontal axis kasi wala tayong ibang mga araw na nakikita along the horizontal axis. Okay? So, after na nakuha natin yung mga reactions, Next, using method of joints. I used method of joints. Kunin natin yung values ng mga members. And in my analysis, ito yung lumabas. Kasanok nga naala ni 0.707. The getting of values, 1.12. 2. Paano ko nakuha itong mga values na to? Again, I used method of joints. Hindi ko na ipapakita sa inyo yung step by step on how I get these values. Again, kulang tayo sa oras. I only have 1 hour. I'll try to finish this before 5 p.m. So, after our class, you may want to solve again these problems. Practicean nyo ngayon nga usaron the method of joints and method of sections. Now, during our midterm, nung narigatan kayo the method of joints and method of section, ibagbagak kanyayo marigatan kayo dito'y truss deflections. Mahaba ang solution or analysis ng truss deflection, and if you are not yet familiar with method of joints and method of sections, magkakaproblema kayo. Okay? So again, try to solve this problem after our class to counter-check if the values I am presenting you are correct. And so again, I use method of joints to get these values. So after na nakuha natin yung ating mga values for each member, para yung ginawa natin in problem number 1, we'll try to input these values on a table. So, yan yung, originally, yan yung forwarded problem. So, kapag ilalagay ko na siya sa table para mas madali yung aking analysis. Saan ko nakuha itong length? Yan. Di ba, given, dun sa problem kanina, given itong mga lengths na to. Yan. Kindly try to browse yung notes na binigay ko sa inyo. Nandun din yung problem na ito. So, try to look at that notes para ma-double check itong length ng mga members. Feet ang naibigay, but I converted that into inches para madalian ako. Bakit ko kinonvert sa inches? If you try to look at what is given, inches yung mga ginamit na unit of measurement. So, para hindi na ako magka-problema, yung length, kinonvert ko na lang siya into inches. Then, for the third column, I considered now the change in temperature. Now, if you try to read the problem, meron siyang, mayroon statement dito na sabi is, the temperature increase of 65 degrees, this should be Fahrenheit. 65 degrees Fahrenheit. So, from that statement, magkakaroon tayo ng idea, meron itong change in temperature. So, I have to take that into consideration. So, itong alpha L delta T, alpha, again, this is the coefficient of thermal expansion, and this is given, that is equal to 6.5 times 10 raised to negative 6 per degrees Fahrenheit. L, that is the length of your member. Delta T, that is the change in temperature. Now, in this problem, it is indicated na yung temperature ay nag-increase to 65 degrees Fahrenheit. So, therefore, itong delta T na to, that is equal to 65 degrees Fahrenheit. So, direct substitution tayo. Alpha, 6.5 times 10 raised to negative 6 multiplied by the length multiplied by 65 degrees. Doon ko nakuha itong 0.090711. For CD, 6.5 times 10 raised to negative 6 multiplied by 135.7 multiplied by 65, that is equal to 0.057333. Kindly double check. Do not just merely look at your screen. Kindly get your calculators and double check if these values are correct. correct. Paki-double check man, nag-comment kayo, no? Check po. Okay. So, since tama tong mga to, our, itong column na to is, this is just the change in temperature. Na kung babasahin natin ulit yung ating problem, may naka-indicate dito na assuming that the existing loading and that member BC is too short by 0.086 inches and member CD is too long by 0.06 inches. So what do this statement mean? Itong statement na to, it will give us an idea na we have to consider fabrication errors. So, dito sa statement, ang sabi doon, si member BC daw ay bitin by 0.08 inches. Yun ang ibig sabihin, si member BC, hindi siya eksaktong 214.7. Bitin isuna by 0.08. Ni member C, dimut, too long by 0.06, meaning ni member CD, mahaba siya by 0.06. Now, from those words na too short, so minus, then too long, plus. As for other members, wala nang minention si problem. So, since hindi na mention si AB, DA, and BD, 0 yung change in length ni AB, DA, at saka BD. Ang may change in length lang ay si BC at saka si CD. Kasi yun yung nakalagay sa statement. Okay tayo dito sa column ng delta L. Now, itong U na to. Saan ko nakuha yung U? Itong value ng U? Galing yan dito sa figure na to. Sa may U system. Na-solve ko si U again using step 2. Step 2, na-discuss tayo dito tatay in the previous slides. So, if you try to look at the diagram, for the values of U, AB has a value of 1.12. Bakit negative? Ibig sabihin, si AB is under compression. Same true with BC. That is under compression, which is equal to 1.12. Si member CD at saka DA naman, CD and DA, is under tension, kaya positive, 0.707. And member BD is under tension also, which is equal to 2. Okay? So, after na nakuha natin yung change in temperature at saka yung fabrication error, tapos yung ating U, we can now add 0.090711 plus 0 multiplied by negative 1.12, that is equal to negative 0.102. And negative 0.08 plus negative, 0.090711 minus 0.08 multiplied by negative 1.12, that is equal to negative 0.012. Again, kindly double check if these values are correct. After na nakuha nyo yung values nitong column na to, take the summation of these values, negative 0.102 hanggang kay 0.081. And in my calculator, my answer is 0.091. Anong ibig sabihin nitong 0.091 na ito? The vertical deflection at joint D due to combined change in temperature and lack of fit is 0.091 inches, direction is downwards. Anong ibig sabihin? Di ba sa problem na to, you are required to determine the vertical deflection at point D, taking into consideration yung fabrication error at saka yung change in temperature. And it turned out in our calculation, yung point D, magdi-deflect siya vertically in a distance of 0.091 inch. And the direction is downwards. Now, it turned out, dito sa calculation natin, this is positive. Ibig sabihin, yung inassume ko kanina na ito, na downwards, yung deflection ni D ay tama. Okay po ba tayo dito sa may problem number 2? Again, problem number 2, combination po siya ng fabrication error at saka ng change in temperature. Okay? Sa problem number 1, yung present ko sa inyo na problem, that is the deflection due to external loadings. Itong problem number 2 na to naman, this is an example of truss deflection due to fabrication error and change in temperature. Now, in case lang for example lang, sa problem, wala siyang in-indicate regarding fabrication error. Wala siyang minention na member BC is too short, member CD is too long. Walang ganyan na nailagay sa problem. So, ang nakalagay lang doon is yung change in temperature. All you have to do, pagdating sa table, alisin nyo lang itong column na to. Then, masosolve nyo na yung deflection due to the change in temperature. So, we move to the third example. If you try to look at books, mostly, kapag sinabing truss deflections, they are concentrated dun sa may deflection due to external loadings. Kasi, kumbaga is, mas malaking factor ang external loadings compared to fabrication error and change in temperature. So, our discussion here will mainly focus on deflections due to external loadings. Kung may mga problems man regarding fabrication error and change in temperature, hindi siya masyadong ganong nakakonsentrate. So, most of our problems are deflections due to external loadings. So, again, for this problem, you're required to determine the vertical component of the displacement at joint G and horizontal deflection at joint E. So, dalawa ang hinahanap dito. Yung vertical component or vertical deflection, displacement or deflection, halos magkapareho lang siya. Vertical deflection at joint G, that is the first thing you have to look at, and the horizontal deflection at joint E. So, again, given ang cross-sectional area ng ating mga members, given din yung modulus of elasticity ng mga members. So, again, step 1 tayo. Ano ang sabi sa step 1? Solve for the support reactions. Tapos, pag na-solve na natin yung ating mga reactions, VE, VA, at saka HA, anong ginawa natin kanina sa problem number 1, using either method of sections or method of joints, kung saan kayo mas convenient, you have to determine the bar forces. Kailangan nating isolve yung mga bar forces. Yan yung nasa step 1. Yung values nitong ating mga bar forces in step 1 is this. Yan yung na-compute ko using a combination of method of joints and method of sections. This, if you try to look at this truss, um, let this be my center line. Ito. Let this be my center line. Now, if you try to look, yung dito sa my left side, pareho siya dito sa my right side. Yan. So, since yung itsura ng ating truss ay pareho dito sa my left at pareho dito sa my right side, this is an example of a symmetric truss. Ganda background ko. And so, since symmetric siya, AB is the same as DE. If you try to mirror AH, the same siya sa may EF. So, kapag symmetric yung ating truss, mas madali natin siyang mas madaling ma-solve yung mga bar forces kasi naka-mirror na lang siya. So, what I did here for this problem, I considered dito sa may left side ng aking truss, and then, in-mirror ko na lang iso na dito yung bangir. Tapno mas nabibiit. But, whatever your or ano man yung ginamit nyo, method of joints or method of sections for the analysis, pareho din naman yung makukuha ninyong sagot. Okay? So, itong mga values na nakikita ninyo sa inyong mga screen, that is the P system. Ito ay step 1 pa lang. Okay? Now, we go to step 2. Ano ang sabi nung step 2? Before I discuss step 2, di ba, balikan natin yung problem. Dalawa yung hinahanap. Yung vertical deflection at point G at saka yung horizontal deflection at point E. So, unahin natin yung vertical deflection at joint G. So, again sa step 2, ang sabi doon, lahat ng mga external forces ay alisin natin. So, inalis natin lahat ng mga external forces. Magre-remain yung mga supports. Then, maglalagay tayo ng apply a vertical unit load at point G. So, at point G, maglalagay ako ng vertical unit load. My assumption here is downwards. So, dito sa step 2, inassume ko na si joint G, magmumove siya downwards. Kaya doon ko nilagay si 1. After na nilagay ko na yung 1 unit load, I'm going to use the static equations para ma-solve ko yung values ni E at saka ni A. And it turned out, at point A, meron akong 0.5 na pataas. At point E, meron din akong 0.5 na pataas. Wala nang horizontal reaction kay A kasi walang ibang horizontal na arrow na nakikita ninyo. Okay? After na nakuha ko yung mga reactions, parang ginawa natin in previous problems. Let's determine the values for each members. So, what I did here again, I used the combination of method of joints and method of sections. So, using those methods, these are my answers. And kindly verify these answers after this class. So, do not just merely stare at your screen. Paki-screenshot, then isolve you ulit iti nga problem. Kasano nga naala dagiti nga values? Again, first, in kabel ko jay, 1 unit load kani point G. In-assume ko the direction nga 1. And then, I solve for the reactions. After that, I used the combination of method of joints and method of sections to determine the values for each member. So, these are my answers. Now, itong negative na to, this means AB is under compression. Itong positive na to, BH is under tension. Okay? After na nakuha natin yung values ng ating mga members, the next thing we have to do now is using a table. So, the first column, nandun yung member. The second column is the length. And, kinonvert ko yung length into millimeters para mas madali. Then, given naman yung ating area, that is millimeters squared. And given CE, that is 200,000 Newton per millimeter squared. Now, baka may magtanong ulit, bakit doon sa problem number 1, hindi ko na sinulat yung value ng A? Hindi ko na rin sinulat yung value ng E. Pare-pareho naman yung mga values. Now, it is your choice. Pinakita ko sa inyo yung dalawang possible solutions using a table. Ada kanya yun niya ti usaran yun niya. Ipakita lang no kasano the procedure step 1 and step 2. And then for the fifth column is the P. Saan ko nakuha si P? In this diagram. Yung value ng P, yan yung mga values na nakuha nyo in step 1. Okay? Now, if you try to look here, let's say kay CD. Kay CD. Kay CD, dito sa diagram, ang value ni CD ay 95.71. Now, you have to take note, yung unit dito sa figure na to is kilonewtons. Okay? Kaya yung 95.71, that is in kilonewtons. Now, dito sa table, yung aking P, kinonvert ko siya sa newtons. Kaya si CD na 95.71 kilonewtons, kinonvert ko siya into newtons, kaya naging 95,710. Same with CF. My CF in this diagram is equal to 27.93 kilonewtons. Nung nilagay ko na siya sa table, ginawa ko siyang newtons, kaya 27,930. Okay po ba tayo dito sa may paglagay ng mga values ng P sa table? Apay nga kinonvert ko iti newtons tapno malakaanak no anak iti next nga procedure ko. Okay? After na nailagay ko yung mga values ng P, I can now input the values of my U. Saan galing si U? Doon sa may step 2. Itong U na to, galing siya dito sa may U system. Again, this is my U system. And this is my P system. Okay tayo? Lagi jay gets yo jing kastak nga nang ikabel jo values dito table. So after na nailagay na natin yung mga values, we can now use the equation PL over AE. So P sa column na to, PL over AE, P that is negative 106,400 multiplied by 3,200, divide it by 1,300 times 200,000. Doon ko nakuha si negative 1.31. Be consistent with your units. Ag-cancel ni Newton, ag-cancel di millimeter squared. So, ang magre-remain na unit natin is millimeters. Okay? And AH, P, 83,130 multiplied by 2,500, divide it by 1,300 times 200,000. Doon ko nakuha si 0.799. It follows with these remaining members. Hindi double check these values. Okay, doon ko nakuha. After na nakuha ko si PL over AE, I multiplied that by U. So, negative 1.31 times negative 0.8, that is equal to 1.048. 0.799 times 0.625, that is equal to 0.499375, and so on and so forth. After na nakuha ko yung value ng PL over AE times U, take again the sum of all of these. Ang lumabas sa calculator ko nung pinag-add ko from 1.048 hanggang kay 0.499375 is equal to 9.45044. So after taking the summation, I can say now that the vertical deflection at joint G due to loading is equal to 9.45044 millimeters. Downwards, positive yung lumabas na sagot dito. So, ibig sabihin, yung assumption ko kanina ay tama. First by lang dating requirement yung problem. So, this is just the deflection of joint G, or this is just the vertical deflection of joint G due to loading. My answer here is 9.4504 millimeters, and the direction is downwards. Okay, so that is the vertical deflection at joint G. If you try again to read the problem, meron pang isang hinahanap dito, yung horizontal deflection at point E. Since sa step 1, nakuha na natin yung value ng P, so proceed ulit tayo sa step 2. This time, ang hinahanap dito ay yung horizontal deflection at point E. Kaya maglalagay tayo ng unit load horizontally kay point E. So, horizontal, again, may assumption here ay mag-move si E to the right. Kaya doon ko ilalagay si 1. Yan. Haan nga gaputa itikab-kabel ko, ipapakita ka na yakot always nga to the right. Sige, no, solve kayo, matkat to the right, to the right, to the right. Mabalin mat lang to the left kayo, ma-check yung mat lang ngayon, no correct dagi nga directions. So, going back to this, my assumption here, ag-move ni point E to the right. After that, solve for the reactions. Wala akong na-solve na vertical reaction. Paano ko nakuha yung 1 dito sa my point A? I used summation of forces along the horizontal axis. After na nakuha natin yung mga reactions, the same using method of joints or using method of sections, we can solve for the values for each member. And lumabas sa analysis ko ay ito. Mayroon akong value na na-solve sa bottom chords. 0 na yung mga ibang members. You can verify my answers if you try to solve this problem again after our classes. So, kindly take a screenshot of this figure na nandyan sa inyong screen and try to solve them later. And verify if my answer is correct. Yan. So, dito, dyan sa diagram na nakikita nyo sa inyong mga screen, positive 1 yung mga values sa AH, HG, GF, and EF. So, ibig sabihin, AH is under tension with a value of 1. Okay? So, again, after na nakuha natin yung values ng mga members dito sa may U system, we can now again put them in a table. So, again, paano ko nakuha si P? Using step 1 kanina. Yung U naman, nakuha ko siya using step 2. So, parang yung table kanina, pinag-multiply, kinuha ko lang yung quotient ni PL over AE. So, kay AB, negative 106,400 multiplied by 3,200, divide it by 1,300 times 200,000. Doon ko nakuha si negative 1.31. Same with the other members. After that, kinuha ko na si PL AE times U. So, negative 1.31 times U, doon ko nakuha itong 0. 0.799 times 1, that is 0.799. Do this in the remaining members. After na nakuha ninyo yung value ng PL over AE times U, take again the sum of all of this from AB to FE. After taking the sum, ang lumabas sa calculator ko ay 3.342 positive. So what do this value mean? The horizontal deflection now at joint E due to loading is equal to 3.342 millimeters to the right. Positive, di ba? Ang assumption ko kanina, si joint E magmo-move horizontally to the right. And it turned out, in my analysis, lumabas na positive si 3.342, which means to the correct the assumption ko nga to the right T, deflection G, joint E. Take note of the unit millimeters. Paano naging millimeters? Magka-cancel out yung Newton, magka-cancel out yung millimeter squared, maiiwan na lang si millimeter. That's why I'm always reiterating, always make sure that your units are consistent. Kasi kapag hindi pare-pareho yung inyong mga units, magiging mali yung inyong mga sagot. And in truss deflections, kung mapapansin ninyo, pag nagkamali ka ng value ng P sa isang member lang, mali na lahat ng inyong mga sagot. Kung mali yung nakuha mong P kay FE, obviously, mali itong makukuha mong PL over AE. Pag mali ito, lahat na ng values mo mali. So, you have to make sure, or you have to always double check your values. Balik-balikan ninyo yung topic natin sa may method of joints and method of sections. Kasi if you are not yet familiar with those methods, ulitin ko, magkakaproblema kayo dito sa may truss deflections. Mahaba ang solution dito sa may truss deflections. Mahaba siya, but if you try to solve more problems, practice lang, mas lesser DJ possibility nga wrong the answer you. What if, di ba, Jigamin, dun sa mga previous examples, pare-pareho yung areas, pare-pareho yung ating module of elasticity. What if ganito yung problem? This problem is in your notes. Ito yung nasa post-test ata to. Yan. So, for this problem, if you try to look at the problem, ang sabi doon, determine the horizontal and vertical deflection component at joint A by virtual work method. So, dito, ang area ni AB, BC, and AC, AB, BC, and AC ay 1 square inch. Yung area naman ng mga ibang members, si member BD, CD, DE, at saka CE ay 2 square inches. So, again, sa previous problems, pare-pareho yung mga areas. But for this problem, magkakaiba yung kanilang cross-sectional area. So, how are we going to solve problems like this? Pareho lang siya doon sa ginawa natin in example number 1 and number 3. So, the first thing you have to do, again, step 1, solve for the reactions at point E and point D. Again, I use static equations and na-solve ko na si E meron 20 kips, si D may 20 kips downwards and 20 kips to the left. K here is kips. Yung apostrophe na nakikita nyo dito is feet. Naka-English tayo dito. Yan. So, after na nakuha natin yung mga reactions, again, using method of sections and method of joints, masosolve natin yung mga bar forces. And after using those methods, ito yung nasolve ko na bar forces. Kindly take a screenshot of this and try to solve this problem again and compare your answers to what is shown on your screen. Paano ko nakuha itong mga values na to? Again, I used method of section and method of joints. Okay? So that is step 1. After step 1, punta tayo sa step 2. Anong sabi sa step 2? 'Di ba sa problem kasi ang hinahanap is the vertical and the horizontal deflection at joint A. So unahin natin yung vertical deflection. So sa step 2, nag-assume ako na si point A will deflect downwards. Kaya doon ko nilagay si 1. After that, take the reactions. So I used static equations. And after using static equations, na-solve ko na 0 ang reaction kay E, walang horizontal reaction kay D, meron akong vertical reaction kay D na 1. Kas ano ka naala dagiti nga values? I used static equations. Okay? After that, again, using method of joints or method of sections, determine the values for each members. And in my analysis, ito yung mga values na nakuha ko. 0 si ED, 0 si DC, BC, AC, and CE. Pero may value ako kay AB at saka kay BD. And as you can see there in your diagram, AB is under compression, same with member BD, under compression. So, itong figure na nakikita ninyo sa inyong screen, that is the U system. Step 2 po yung nakikita ninyo. Okay? After that, i-table natin para mas madali. Parang yung previous examples lang. Now, itong U na ito, UV yung ginamit ko, which indicates ang kinukuha ko dito ay yung vertical deflection at joint A. Bakit ko nilagyan ng V? Kasi sa problem, isang joint lang ang kinoconsider natin. Kaya, may vertical deflection tayo kay joint A. Kaya ko dito nilagay na UV. Yan. So, follow na lang natin yung ginawa natin in the previous examples. After na nakuha natin yung PL over AE times UV, you take the sum of all of this and lumabas sa calculations ko, negative 0.096. In the previous examples, pare-pareho yung value ng ating cross-sectional area. But for this example, iba ang area ni AB, ni AC, at saka ni BC. Iba ang area nila kay BD, CD, CE, at saka DE. Yan. So, kapag hindi pare-pareho yung mga area, ganito na lang yung gawin ninyo para hindi kayo mahilo. Yan. So, in length, ang given kasi sa problem is feet. I converted the feet into inches. Bakit ko siya kinonvert? If you try to look at here, KSI stands for kips per square inch. Kips. Ang K natin ay kips, so magka-cancel out lang yung kips. SI is square inch. Magka-cancel out lang din to. So, ang matitira na unit natin ay inches. Okay? So, again, if I'm going to take the sum of all of this PL over AE times U, that is equal to negative 0.096. Negative yung lumabas na sagot ko. Anong ibig sabihin nitong negative na to? Diba, ang assumption ko kanina, etong point A will move downwards. Kaya yung assumption ko, itong green arrow na to ay pababa. Pero lumabas sa calculations ko, negative. Ibig sabihin, mali yung assumption ko. So, the final answer here, yung vertical deflection at joint A is equal to 0.096 and the direction would be upwards. Okay po? Yan yung ating vertical deflection at point A. Any question before I go to the next slide? So, naawan ti question, nag-proceed na. Ang next requirement sa ang nasolve na natin is the vertical deflection at A. This time, let's solve for the horizontal deflection at A. Horizontal deflection, hindi ko na uulitin yung step 1 kasi na-solve ko garo din, di ba, GP? So, this time, I'm going to consider now step 2, pero ngayon, yung horizontal deflection at A. And this time, I'm going to assume na si joint A, mag-move siya to the right. Kaya doon ko nilagay si 1. So, again, ulitok, no, apang kayo ti step 2, always ikatan nyo amin nga external loadings, tapno maikabel yu jay unit load. So, here, I put 1 unit load to the right at point A. So, after that, I determine the reactions at E and D, and ang nasolve ko, yung mga values na yan. Double check this one using static equations. Yan yung mga nasolve ko. Do not merely stare at your screens. After na nasolve yung mga reactions dito sa my supports, again, I used method of section and method of joints para makuha ko yung values ng aking mga members. And yan ang lumabas sa aking calculations. Paano ko nakuha yung mga values na yan? Again, I used method of section and method of joints. Take note of the direction of the arrows. This is step 2 for the horizontal deflection at joint A. Inputting this sa my table, again, nasolve na natin kanina si P. Yan. Solve ko na si P kanina. AB, ang value ni AB ay 13.33 kips. And since the direct since the direction of the arrow is away from the joint, so that is tension, kaya positive yun. Okay? Again, wag niyong kakalimutan kapag compression, negative. Kapag tension, positive. Then, saan ko nakuha yung values ni UH? Itong UH na to, galing siya dito. Okay? Take note again of the direction. And then, PL over EE times UH, doon ko nakuha itong values na mga ito. So, 13.33 times 96 divided by 1 times 20,000 multiplied by 1.33. Doon ko nakuha si 0.085. And double check these values. After na nakuha ko yung mga values ng PL over EE times U, take the sum again. So, 0.085 plus 0.016, lahat ng mga values na ito, take the sum of it. My answer is 0.474. And my final answer is, the horizontal deflection at A is equal to 0.474 inches to the right. So, lumabas sa calculation ko, positive. So, ibig sabihin, again, kapag positive, pag positive yung lumabas dito, yung assumption ko kanina na to the right ay tama. So, okay tayo sa virtual work method. I understand na nakakalito pa siya. But as I've said a while ago, kindly make yourselves, kindly be familiar with method of joints and method of section kasi yun yung gagamitin talaga natin in truss deflections. Basta ulitin ko sa may step, again sa step 1, dito sa pagkuha ng values ng P, sa step 1, always ang unang gagawin ninyo is to take the reactions and then take the bar forces using method of joints and method of section. This is step 1. Sa step 2 naman, alisin lahat ng mga external loadings, tapos i-apply ninyo yung unit load. Yung pag-apply ninyo ng unit load, yung direction, depende kung ano yung sinasabi ng problem. Kapag yung sinabi ng problem ay vertical deflection, yung inyong unit load is either up or down. Kapag ang sinasabi sa problem ay horizontal deflection, yung unit load ninyo ay either to the right or to the left. Then after that, solve for the reactions, and then again, using method of joints or method of sections, isolve nyo yung mga values ng mga bar members. Okay? So that is truss deflection. Now, if you try to look at your notes in page 4, this is a post-test. I've already discussed with you on how to solve this problem. Padasan nyo ngayon manan nga i-solve dating a problem without looking the video to nga i-post ko on the process to kasanok nga na-solve. There is already an answer here. Try to solve this problem again. Then, ipadas yung ngayon no, at dati malagip yung kadagit sa inbagbagak. For page 5, you have your follow-up work. Again, this is a laboratory exercise. So, group work ito. And there is an instruction indicated there on what are the values for your P and your L. Pwede po ba kapag nag-submit kayo ng inyong laboratory exercise for these finals, let's say in your group you have 4 members. Sa 4 members na yon, isa lang ang magta-turn in. Okay? Haan nga amin kayo ag-turn in kasi makapaulaw ngay. While I was checking in your previous activities, i-open ko dyan may isa nga file, tapos i-open ko ulit dyan may isa agpadadagayam. So, it takes time. Haamot nga dagos nga i-click mo nga kat agparang nga dagos. So, ag-loading pa lang diay. Now, to lessen time, pwede po ba isa lang ang mag-turn in or magsasubmit ng mga activities? Diyan lang representative view. Baka may iba sa inyo, missing mat gamin ti agparang iti Google Classroom ko. Okay lang nga missing ti agparang. Ti importante ijay, you have to make sure na yung inyong representative ay ita-turn in yung inyong activity. Okay? Make sure nga DJ representative view i-turn in na diay. Tapno uno nag-check na oray missing kayo, mabalin ko lat nga i-input it score. Are we clear on that? Pangaasiyo, may salang ti ag turn in ije group view. Okay po ba?